Hello and welcome to Maths Bites, where we discuss maths topics related to computer science. This is the 11th video in the binary numbers series, and in this video we will be discussing decimal addition, which in turn will prepare us for better understanding the binary addition in the next video. While we revise the decimal addition, we will also focus on the concept of the carry and clarify its role. Next, we will also think a little about why the addition is carried out the way it has been taught at school. In the final part of the video, we will come up with a set of instructions for adding decimal numbers together. Then, these instructions will become the foundation for binary addition in the next video. So, let us get started and review how we add two decimal numbers together. Can you try to add together 679 and 4386? I will stop talking for a few seconds, and I would like you to have a go at this calculation, but rather than focusing on getting the right answer, try to focus on how the addition works. What do you do when adding these two numbers together and why? Here is one way of doing the addition. I will refer to this as the traditional addition. First, when we add the two decimal numbers together, it is very important to line them up correctly, so the same place values are under each other. We can ensure this by lining them up so that the rightmost digit, the unit digit, are under one another like this. In my opinion, it makes things a little easier if we write the longer number on top of the shorter number, but it is not necessary. However, we should always write out the plus sign, so we and anyone else knows that it is an addition we are doing. It is also common practice to underline the bottom number. The role of the line is to separate the addition from the answers. Now that we are all clear on the right way to set up the addition, let us focus on what happens during the addition. When we are carrying out the addition, we are adding the two numbers together digit by digit, starting with the rightmost digit. When we add the single digits 6 and 9 together, the result is the double digit number 15. So we write down 5 into the results unit column, which is the rightmost digit under the line, and you record a 1 into the tens column as your carry. Then we move on to the next column, the tens column, and add together 1, which is the carry from the units column, and the digits of the two numbers at the tens column, which are 8 and 7. These three numbers add up to 16, so we need to record an extra 1 into the hundreds column as a carry, and write down 6 into the results tens column. Then we move on to the hundreds column and add together 1, 3 and 6. They add up to 10, so 0 goes into the results hundred column, and the 1 carry is recorded above the 4 in the top numbers thousandth column. In the thousands column, we originally only had a single digit of 4, but now we also have a carry of 1. Adding them together, we get 5 and no carry this time, so we record the 5 in the solutions thousand column and we are done. The answer is 5065. Now, we know how the addition is being carried out. Let us think about what happens at the fundamental level. Let us use the same example, but now set the addition up in a slightly different way. For this, we will use a nice grid. This table has useful headings that help us record the right numbers in the right places and hopefully will help us draw attention to what happens in the addition behind those single-digit calculations. The column headings numbers will be used to record the original numbers in the respective rows of number 1 and number 2, which are shortened to NO1 and NO2. In the place value columns, thousands, hundreds, tens and units, we will write the corresponding values of the two numbers. Again, I will write the longer number above the shorter number. Then we also have a separate row for the carry, which is the first row in the table above the two numbers. The last row in the table is the row where we will record the result of this addition. It is again separated by a thicker line to separate the workings from the result. First, let us break up the numbers 4386 and 679 into their place value sums, like this. And now place these into the table in the corresponding cells. Now we will add the two numbers together again. We start with the units column again and add together 6 and 9 to have 15. Now, we have a two-digit number that can be broken into its place values of 5 and 10. So in the sum row, we can write 5 for the units cell, and the 10 should go into the carries rows of tens column. Now the units are added, so we can move on to the tens column. We have 80, 70 and 10 in this column, and these add up to 160. We record 60 in the tens column's sum row and 100 to the carry row in the 100 column. Next, move on to the 100 column and add together 300, 600 and 100. These add up to 1000. 1000 has no hundreds, so we can put a 0 into the results row and place 1000 to the carry row of the thousands column. Now we only have the thousands column left to deal with. In this column, we have 4000 and 1000, which adds up to 5000, which is recorded in the sum row. Then finally, we can add up all the different place values together to get 5065 as our final answer to the addition of 4386 and 679. I do hope that this grid is helping you see what happens in the traditional addition method at the background and how the carry plays a role. For example, when in the traditional method you add the digits 3 and 6 and the carry 1 together in the 100 column, you are adding together 300 and 600 and 100 in the background. Every time you are recording a 1 as a carry into the next column, that carry is 10 times larger than in the original column. For example, 8 and 7 and 1 adds up to 16, and the 1 carry is the 10 of the 16. As they are all in the tens column, the carry of 1 represents 100, which is 10 times larger than the original place value of the digit 8 and 7, which is the tens place value. I hope you see why I wanted to make sure we all understand the decimal place values in detail. I believe they helped us greatly in deepening our understanding of the binary number system, and now they help us with decimal addition and consequently with binary addition in the future. I hope I haven't made your head spin too much talking about a process that you are most likely very familiar with in a somewhat alien way. Perhaps you never thought about addition the way I presented in the last few minutes. However, most successful programmers do exactly this. They break down processes that are familiar or intuitive into small, basic steps with extra consideration to how the computer would be able to handle this. Basically, they also think about what codes can and can't do. So if you really want to push yourself to the limits, I challenge you to create a small program in your chosen language that adds two decimal numbers together. Have fun! I have another question for you. Why do we start the addition with the units and not with the highest digit on the left? Well, let us try to do the addition by starting with the leftmost digits and see what happens to determine why it is not the right method. It often helps trying to do things in a different way so you can build a deeper understanding of why the preferred method is the better way of doing this. I believe in getting into the habit of trying to do familiar things in a different way and kind of trying to break a method. You will be able to develop true mastery, and you might even come up with a more efficient way of solving a particular problem. So, we will add 4386 and 679 again, but this time we will start adding the highest place values first. So, 4 has nothing underneath, which means nothing needs to be added to the 4. So we can record 4 into the results under the line. Next, move on to the hundreds column and add together 3 and 6. These two digits make 9, which can be recorded as the result under the line again. Next, move on to the tens column and add together 8 and 7. These digits make 15, so we have a double digit here. Now, what are we to do with an extra digit, this carry? In 15, the one is a higher place value. But we have already dealt with that place value in this backwards way of addition. Now we have to go back and modify what we already done. We would have to add 1 to the 9, and this in turn would add 1 extra to the 1000 column too. This is clearly an inefficient way of doing the addition, as we have to keep going back and modify our results of previous work. I hope this convinces you that starting with adding the smallest place values makes the addition process fast and efficient, as in those ways, when you are adding the next digits, the smaller place values are always 0, so you're adding nothing new to the smallest place values. If you have never thought about the decimal addition this way, and you feel this is going above your head a little bit, please do watch the video again. It can be hard thinking about something very familiar in a totally different way, but I truly believe if you grasp the main ideas of the decimal addition, it will be much easier to understand the binary addition and not just learn some obscure method that you are likely to forget as soon as the exam is over. Now let us think about the carry a little more. I will only concentrate on what happens to the carry when we add together 2 decimal numbers. You are more than welcome to think about and modify this process when adding together more than 2 numbers. So what is the biggest carry we can have when we add 2 decimal numbers together? Well, the largest decimal digit is 9. We can have 2 of them in any one addition. So the maximum single digit addition can be 18. But what if we already had a carry from the previous column? Well, in that case, we could have an extra 1 added to our 2 9s, which altogether would make 19. For example, when we are adding together 195 and 97. In this addition, the units makes 12, so we have a carry of 1 in the 10th column, and adding 9, 9 and 1 together makes 19. So we write down 9 and carry 1. Finally, 1 and 1 of the carry in the hundreds column makes 2. So the answer is 292. This indicates that when adding 2 decimal numbers together, we cannot have a carry more than 1. This knowledge provides us with an opportunity to check a method. When we are adding 2 decimal numbers together and we record a carry of 2 or more in any one column, we have made a mistake and we better check our sum again. Remember, this only holds for adding 2 decimal numbers together. When adding more numbers, the biggest carry needs to be modified accordingly. Try to think about what the maximum carry would be when adding together 3 decimal numbers and share your ideas in the comment section. Now, let us do one more addition of 2 decimal numbers so we can see the process in a more natural flow without having to spend much time explaining each step, and use this opportunity to think about and concentrate on what steps are taken and how we could write this process up into a neat step-by-step instruction. Let us add together 9,682 and 10,197. First, we line up the 2 numbers so the place values match. For example, units are under the units, tens are under the tens, and so on. Placing the longer number at the top like this. Next, we record an addition sign at the front of the bottom number and underline the sum like this. Now we are ready to start the addition. First, add the 2 digits at the units place value. 7 and 2 makes 9. This time we have no carry, so we just record the 9 in the results unit column. Next, we move 1 place value to the left and add the 2 digits together. 9 and 8 makes 17. This time we have a carry. So record the 7 into the results 10 column and record 1 as a carry above the top number's hundredths column. Again, move 1 place value to the left and add the digits together. We have 1 carry, 1 and 6 from the original numbers. They make 8, and this time there is no carry. So copy 8 into the results 100 column and move 1 place value to the left. In the 1000 place value, we have 0 and 9. This makes 9. Again, we have no carry, so just record 9 in the results 1000 column and move 1 place value to the left. In the 10,000 place value, we only have the digit 1, no carry and no other digits. So we just record this into the results final place value. This will give us the result for the sum of 10,197 and 9,682 as 19,879. Now I would like you to pause the video here and try to write down some kind of step-by-step instruction for adding together two decimal numbers. Here is my version of the instructions. Again, I appreciate that this was difficult. However, as we now have a go-to process for the decimal addition, it will be easier to write one for the binary addition in the next video. Please compare your algorithm to mine and see if you have the main points and if your instructions are clear enough. The easiest way to assess this is to share your instructions with a friend and ask them for feedback. Do they understand your instructions? Would they be able to follow through the whole process? If not, at what stage are they confused? Which step, sentence causing confusion? Try to seek feedback on your work as soon as possible. Instant feedback has been shown to have a great effect on learning. That is why you see me giving you the answers to all the questions I ask. I want to provide you with the most effective learning experience. Let us now summarize what we covered in this video. We started by revising how we can add together two decimal numbers using the traditional addition method. Then we picked this method apart and we tried to understand what happens at a fundamental level beyond the mechanics. We discussed that when we add the decimal numbers together, we break the numbers into their place values and add the corresponding place values together. We also presented the decimal addition in a structured way using a table, so the calculations that are usually done in the background could be emphasized. We also spent time discussing the role of the carry and established that when adding two decimal numbers together, the max carry we can have is 1. And in the last part of the video, we have written down a step-by-step set of instructions for adding two decimal numbers. Next time, we will discuss how to add binary numbers together. And we will use the addition algorithm we developed today and will modify this for adding binary numbers together. I hope to see you in the next video. Until then, keep learning, one byte at a time.